So in this example, PC1 wants to send data to PC2. But as you can see, now there are two switches between PC1 and PC2. We have switch 1 and switch 2. Let's try to add VLAN information and see what will happen when PC1 tries to connect to PC2. So switch 1, let's add a color red. On switch 2, let's add the color red as well. When PC1 tries to send data to PC2, the data will go from there to here. The switch will then receive it inbound, so it will add the color red to it. So from black, it will turn to red. It will then ask itself, what are the interfaces that have the same color? But as you can see in the diagram, it does not have any. So what will the switch will do is that it will drop the data. So as a result, PC1 won't be able to connect to PC2, or PC1 won't be able to send data to PC2. So one thing that we can do so that PC1 would be able to send data to PC2 is that we can add VLANs between switch 1 and switch 2. So let's add VLAN red to switch 2 and switch 1. So red here and red over here as well. So let's see what will happen. So when PC1 tries to send data to PC2, the data will come from there to here. The switch will then receive it inbound, so it will add the color red to it. So from black, it will turn to red. From there, the switch will ask itself, what are the interfaces that have the same color? So the switch will then send the data out to the interface with the same color. So it sees Ethernet 02. So from there, the switch will send the data outbound. So the data will be stripped out. So from red, it will turn to black again. Switch 2 will then receive it. But as you can see, this interfaces has the color red. So in turn, if anything is received there inbound, it will also add a color red to it. So switch 2 will add a color red. So from black, it will turn to red again. And then from there, switch 2 will ask itself again, what are the interfaces that have the same color? So it sees that Ethernet 02 has the same color, so it sends the data out there. Sending out, it will strip the data out. So from red, it will turn to black, and then it makes its way to PC2. So as you can see, when PC1 tries to send data to PC2, it will be successful. It is because from here to there, it has this layer 2 connectivity. But what if PC3 suddenly wants to send data to PC4, but both are on different VLAN from PC1 and PC2? So let's try to add a color blue for both switch 1 and switch 2. So blue here and blue there. So when PC3 tries to send data, PC1 will receive it inbound. It will add a color blue. So from black, it will turn to blue. The switch then will ask itself, what interfaces have the same color? But as you can see, it doesn't have any. So again, it will drop traffic. So that's the time when we can use a trunk. So what is a trunk? A trunk is like a tunnel in which all VLANs can pass through. So let's try to make a tunnel. So from switch 1, let's make a tunnel from there to here, from there to here. So let's try to see what will happen. So when PC1 tries to send data to PC2, it will send data out there. From there, it will add VLAN information, it will add a color. The switch will then ask itself, what interfaces have the same color? But as you can see, we have this tunnel that all VLANs can pass through. So it will just pass through this tunnel, this trunk line. The switch 2 will then receive it. From there, it will ask itself, what are the interfaces that have the same color? It sees Ethernet 02. And then from there, it will strip out the data, making its way to PC2. So how about here on PC3 to PC4? So when data is sent from PC3, the data will go from here to there. Switch will then add VLAN information to it. It will add the color blue. It will then ask itself, what are the interfaces that have the same color? But it sees that it has a trunk link. So every VLAN can pass through there. So it will pass through there untouched, without stripping or without anything. So again, switch 2 will ask itself, what are the interfaces that have the same color? So it says that Ethernet 03 has the same color. So again, in turn, it will pass through there, outbound, and then it will strip the data out. So as a result, PC3 will now then be able to send data to PC4. And likewise to PC1, it will be able to send data to PC2. So that's the end of this lesson. So I hope you enjoy and you learned a lot. So goodbye and God bless you.